So now today. So today we are going to solve the array problem. Like we have solved all these problems, right? Now we have to solve hard problem. First, let's go with the Pascal triangle, majority element 3 and 3 sum. I think 3 sum and 4 sum I have already solved it. Like let me show you. You if you go to my channel, you can see that the 3 sum problem. I solved 3 sum and 2 sum. Okay, all the sum related problem I have solved in this video. Okay, not just so these two are solved. Now some largest array with some 0 and the count of with the given XOR. Okay, and the merge overlap interval. Let me first solve these three problem. Okay, first let's understand the Pascal triangle. Oh, I think this is solved. Like so, this is the simple problem. Like we have to use, like as you know, the Pascal triangle right here. As you know, the Pascal triangle, right? From one, we are like taking 1 plus 1. We have 1 1 1, and taking for the previous row, current element or the next column, just like this, right? So this is this one easy problem. So let's not go for this. Let's understand this problem. You have given that integer array of nums n, and you have to find the all the element that appears n by 2. So just you have to find the all the element, not all element. You have to find the element more than all the element, right? So you have to just find the which frequency you can. We can use here the map, right? So n is equal to nums dot size and the unordered map. Sorry, unordered map in this is for the frequency, right? Frequency. Now we have to store all the frequency here. and the nums frequency plus x plus plus, right? Now just we have to take a array which return the result. Now just iterate iterate through the map. Okay, frequency map, frequency map, and just find that if x dot second is greater than and by 3, we have to just store push back x dot first. This is the simple brute force approach, right? And we have to return the result. This is the brute force approach. Yeah, this is the brute force approach, right? Now, how can we solve it in optimal way? Like what can we do in optimal way? Like from the sorting 2 3 3. If we apply the Moore's sorting, I don't think this gonna solve it. So how can we approach how can we approach this? How can we approach using optimal way? Right, if we move sorting, there is an algorithm for finding like Moore's Moore's sorting algorithm. Yeah, yeah. This is find for the majority element. Efficient algorithm to find the occurrence of the. This is the optimal way, right? What we have to do. If the vote is zero, we have to make that element itna. If else, if array, we have to count, not a count. If in, so we have to just. Now, how can we approach using this of this element? I don't think this is the optimal way. Let's see the other solution and no skirting. So I think what is this time complexity? So it's an most wire with solution has map on most wire. Let's see how it's applied as to for every brute force approach. This is the has map and most working. So problem statement this institution 4. So answer is 4. Answer is 2 or 4. Answer is 2 4. How can we approach this? Like it's more like a structural. It's used an unordered map, right? So this is good. And the most voting. I yeah. This apply most voting. This is candidate 1 2. Candidate 1 not equal to so candidate 2. Candidate 1. Candidate 2. Threshold frequency itna. And the candidate count of 1, count 1, count 2 is the threshold is different. So this supposes that only 2 votes are present. Okay, this is good. Now let's move the next question. So I think this one is a good concept, right? Using the frequency and checking that if frequency is greater than by 3, then we have to push back. We can apply the Morse majority voting algorithm, but it is efficient for the only for n by 2, right? And as finding to single element. What what if the more than one element is in whose frequency is more than n by 2 3? So it's a little bit complicated, right? Let's move the next question. What this question said that you have given the array containing both the positive and negative integers. Okay, your task to find the length of a longest subarray with a sum equal to 0. Okay, so just like this, you have to find the longest subarray with the sum equal to 2. So we can use here the map approach. Like they I- like in this question, they asked me to longest survey, right? So how can we approach like if MP is equal to 0, then we have to 0. It's 15. So it's a 15 is equal to I, but that means 0. 20 is equal to 22 is equal to 1. We have to map minus I. We have find 30. It's a 20. Then we have to find minus 1, 8. Sorry, 0, 15, 0, and 21. Now we have to 20 plus 14, 2. Now we have to minus 1, that means 6, 6, 3. Now we have to 7, 4. Now we have to 10, 17, 5. We have to just find now. Right, 30 minus, that means the 30, 20, 20, okay, 20, 20 plus 20, 24, okay, 4, 2, okay, that's good. Now minus 1, 14 minus 1 is 6, 6, okay, 6 and plus 1, 6 plus 1, 20, and we have to find 7, 7 plus 7, 14, so it's become 14, yeah, it's 14, it's become 14, so it's approved. How can we approach like this? Let's suppose we have find, and let's let's approach with the 0 sign, right? uh, Int the prefix sum is equal to 0, and the map mp, and mp0 is equal to minus 1. Now let's suppose 4, yeah, 0 and plus plus. What we have to do? Prefix sum, sum plus is equal to area I, right? Area I. Now let's find the remainder. Remainder, what will be the remainder? Remainder, there will be the, what will be the remainder? So it's remainder will be the, I think, if it is 0, if it is 0, right? If the sum, if the prefix sum is 0, it's equal to 0, just we have to the max length is equal to max of max max length and I plus 1, right? Else we have to find remainder, like what will be the remainder? No, just we have to find the sum 0 now, so just minus prefix, this is the remainder. And if mp dot count count the remainder if it is present, so we have to just maximize the length, max length, and the I minus mp dot remainder. Just just we have to, I don't think so, sir. Yeah, else 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 mp dot prefix sum is equal to I. Now just take the max length is equal to 0. Now we have to return the max length. One approach, I think this is the right one. Let's see. What is the max? This is the max length is equal to sum is equal to 0. We have to not to find, not to approach. Hmm. If prefix sum becomes 0, so we have to find the 0. Sum is equal to 0, right? Sum is equal to 0. Hmm. If the find, if the prefix sum is fine, so all the prefix sum, just, just remove here. Why the minusing from the 0? Yeah, this is the approach. Like what we have to do? They are asked to the find making the target 0, right? So we have to just do like if the target is already found somewhere, we have to just take the length of that. Else we have to store the length of that. This is the simple problem. Now let's move the next problem. Okay, sorry. So next problem is like count the subarray with given XOR, right? So count the subarray with given XOR. So in this problem, you are given that count the subarray with given XOR. You are given the nums and the k, and you have to find the subarray that having the XOR is equal to 0. Okay, XOR is equal to 0. This is a good problem because it's involved the bit manipulation, right? What we have to do, 2, 2, 2, 6, 4, k is equal to 6. Now what we have to store here? What we have to do a store here? Like just just now we have to just uh, 0 is equal to 1. Now let's suppose 6 remainder is equal to 6 XOR 6. We can't find this. We can't find this. It's the 1 0 0 1 0 1. So it's the 1 0 1. So it's a 2. 2 is equal to 1. Now, now, now again, it's the XOR is 4, right? 4, 4 is equal to 1. And now 2. 1 0 0 1 0 1 1 to 1 0 1, right? 1 0 1 and the 1 1 0 6 and 1 0 0, right? So we have to store like a 4, we have to store like a 6, right? 1 1, we have to store like a, we have to store like a here, what we have to store, what we have to store here, just we have to store 4, that means 4 is equal to 2. Now what we have to do, just we have to find now what we have to find, like uh, 0 is equal to 1, 4 is equal to 1, and now 6 is equal to 4, 2, not found. So it's like 4 is equal to 1. Now 6 is equal to 6, it's found because 2 or 6, 2 or 4, 6, so it's a 1. So it's a 1. Now store the XOR to the 6, 6 is equal to 1, 6 is equal to 1, not a reminder, but 6 is equal to 1. Now we have to 4 2 2 6 4. Here 6 4 store 4 1 6 1 0 1 0 1, answer 1. Now just 4. So we have found, yeah, we have found 4. 4 is 0 6. We have found the or 4. So it's a 2. So 4 2 2. This we found that What is this? So it's a pawn, right? It's for each pawn, right? Yeah. No, 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 no. Can't. So let's suppose what I'm trying to do here, like int and is equal to array dot size, right? Let's suppose we use the map, like a map int, sorry, int and mp. mp 0 should be 1 and take a long answer equal to 0 and 4. Let's check the prefix XOR 0, right? Just we have to prefix XOR with, suppose XOR with array I. Now we have to find remainder. What will be the remainder? Remainder will be the prefix XOR if mp dot count the remainder. Just we have to add answer plus mp dot remainder, right? Now else we have to just add the prefix XOR plus plus. Just now we have to return the answer. Is this giving the right answer or a wrong answer? This is the simplest problem. Giving the right answer, right? This is the good problem, right? What we have to do, just like the sum problem, like count the subarray with given sum, like count the subarray with given, count the subarray, count the subarray, count the subsequence of subarray with sum is equal to 0. Just like this, we have, sorry, yeah, just like this. Same approach, same problem here. We have solved it in uh, just just like same problem I have done here. Just we have to replace the plus sign plus with the XOR. That's it in this problem. Let's move the next problem of the interval, merge overlapping interval. It's a bit a greedy problem, right? What we have to do? Given the intervals, a start and end, merge the all overlapping interval and return the array of non-overlapping interval. Okay. So what we have to do? 3, 6, 10, and 15. First we have to sort, right? First we have to sort. Now, like it's a merging. So 1, 6. It's not a merging. So 10, 10, and 51. So what we have to do? Just so we have to merge the interval, right? Right? You have to merge the interval. Now, what we can do? So we have to just, I think it's not already sorted element. So we have to sort first, right? Just we have to see the element, right? What we have to do? Just take this intervals dot size, and just sort the intervals. What is saying? Replace with XOR of adjacent. What is this? Is a problem? Yeah. Replace. Replace. What is the problem name? Replace with XOR. Replace with XOR. XOR with adjacent. 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 It's a problem. What is this problem says? Let's see. So this problem says you are given the array of integer, replace each element with the XOR of its adjacent element. Okay. So at index 1, 1 and 2, at index 2, 2 and 4. Okay. So at index 1, 0 or 2. At index 3, at index 1, once this and this, right? And at index 1, at index 2, 1 and 7, right? Okay. Now it's index answer. So what you have to just do nothing on this, I think. Let's suppose that we have to the first just you have to use, okay, so 2 1 4 7, we have to just, let's suppose 3, array 0 is equal to 3. Now we have to use 3 and 3 and 4. Yeah, in this question what you have to do, just take like a like array nums. Now how can we proceed? Like first we have clear like a first we take the element 1 plus 2, this is right. Now take the, so it's a 3, 0 XOR 3, it's a 3, 3, current element you have a 3 है ना, 3 है, इसको ले रहे हैं, राइट, और इसको ले रहे हैं तो क्या होगा, यही ले रहे हैं, तो क्या होगा, क्या होगा, XOR 4. Yeah, what we have to do this, I think the boy version not ATS official. So as you know, XOR, this problem suggests that you have to take XOR of adjacent element, right? So let's suppose you are present on a zeroth element zeroth index, so you can adjacent 0 or 1, right? If you present on 1th index, you can take like a adjacent of, take XOR of 0 or 0 or 2, right? So what we can do like here, let's suppose we are in a present of index 0, so we can take I XOR I plus 1, right? And we can maintain a variable which store the current XOR, right? So let me write the code like one is current XOR is equal to 0, right? And the yes, and just we have to just put it at like 0 and minus 1 plus plus, just what we have to do, like we have to make a xx equal to like the current XOR this, and I XOR I plus 1, right? Now array dot I is equal to xx. Now current XOR is equal to XOR XOR xx is equal to xx, right? Now at the last index, at the last array of at the last and minus 1, we have to just put it the current XOR, and we have to just nothing. So this is the right. Okay, so I think what we had to a I not define array. So just we have to do this, right? Yeah, this is okay. So current today is UTT, right? I don't think so. So what I'm trying to do here, let's suppose I maintain a current XOR like I maintain like a XOR of this full. Let's suppose first of all the current XOR like 1, 2 and 1, right? 2 and 1. So XOR of this is 3. Now we have moved to index 1. If we move the index 1, what I am doing, we are taking like 3 3 XOR 1, 3 XOR 1 XOR 4, right? So what I am doing here, the my previous current index is like 2 XOR 1. Now my next index with is 1 XOR 4. So tell me, the 1 and 1, the XOR of same element become 0. So it's become 0. So it's completely removed, and the final version will become 2 and 4. So it's the adjacent. 2 and 4 is the adjacent of this. Now at last, what I'm trying to do, like I removed again, right? So in a current, I have removed like a current a store like a 3, and we get again like what is this 2 6, so 6 XOR of 3 and XOR of 6 we just remove, so it's become 5. We have to just remove this, right? So this is the solution of today exhaust. Let's move the my solution like the merging interval. So we can sort the merging interval, right? Interval, we have sort the merge interval. Now let's move the next question. Let's, if we sort it down, so what is that, right? Let's suppose let's take the left equal to interval 0 is equal to 0, and the right is equal to interval of interval of intervals intervals of 0 and 1. This is now let's move to the index of 1, index of n, and index plus plus. Now, if what we what we have to do, we have the 1 and 3, right? So what suppose let's we can do here? What we can do here, like if the we can find the current left, it's the interval 0, sorry, I and 0 0, and interval of sorry, and the current right is equal to intervals of I and 1, right? Now if it is out of index, out of bound, like how can you check the current left is greater than the right, or the current right left is greater? It's a out of bound index, so we have to just answer dot push back. What we have to push, we have to push like left right, left left comma right, right, and we have to just put the current left and the right of current right. Else what we have to do, else what we have to do, as what we have to do, we have to just max current left is equal to minimize the current left and the current. Oh, what we have to do, just no, I don't think, just take from the this much perspectives left, and the current right should be the maximum of the right and the current right, sorry, current right. Now just after after push left and right, just take a just take a answer, just take a answer, and we have to just return the answer. Let's see this passes the test cases or not, or this take required answer to push back. Okay, push back. I have a knowledge to due to my the competitive programming I fail 1 3. So we have to just what 1 6. So current left. What will be the current left? Current left should be 2 and 6. 2 and 6, 1 and 3. Current left is greater. Okay. Sorry. How can we proceed like this index is out of bound? How? If the current left is greater, if the current if the current left is a greater, right, 1 and 3 is a left and right, and the current left is 6 and right. So this is the bound, right? Now the current left should be greater. No. Left is greater than the current right. Current right. Like suppose we are here to 1 and 6, and it's come that 1 and 10. Now this is left and this is right, right, 1 6 right, 1 and 6 is a left right range, and the current left is 10 8 and 10. So what we have to do, like the left, like current left should be greater. If it is greater than the right. Okay, yeah, greater than the right, greater than the right, current left is greater than the right, and the current left, and the current left, it's a current right, and what is left? Left, left is greater than, this is the approach. No, current right is greater, current right is greater, current left is greater than right. Yeah, this is answer to put left right. So how can it approach like this? How? You are storing that index 1 and 6, 10 and 3, 2 and 6. Why not 2 and 6? Why 2 and 6? The current right, current left, 2, 6. 2 and 6. 1 and 3. Left and right. 2 and 6. 2 and 6. Current left, current right. It's greater than the, no, it's greater than, no, it's not a greater than. So let's take like current left. It's not a current left, right. It's not a current right. How can you proceed like this? So it's a current left is current left 2 greater than 1. No, 3. So it's a false. So it's some else position. So we have to just left 2, 3. Oh, what? Why? I think this is right. But why are you this? I think just remove it. No. I don't think this. We have to just remove it. Current left answer 1, 3. 1, 3. We are maximizing now. Just remove the else condition. Else condition. We could just remove the else condition. 1, 3, 1, 8. I think I made a mistake. Right. Current right. Okay. Sorry. What I am doing here, we are updating the current right. We have to update the left and right. That's why this giving the, what is, I think, yeah, this is pass. So we are checking like, this is the condition we are checking like, if the, this is the out of bound, right? So we are storing, and we know that out of bound, that means we have completed interval one interval. Now let's move the next interval, right? One, let's suppose 1 and 3, and 2 and 6 is in between the 1 and 3, because 2 is coming between 1 and 3, so we are merging this. Now 8 and 10 is completely different, completely out of bound from this, because it's the left is greater than the right of the range. That's why we are checking that current left is greater than the right, or the current right is, that left is less than the current right. eh, Left is greater than the current right. So we know that this interval is out of the bound. That's why we are storing, right? This is the solution of merge interval. There is many solution of this merging, and lot of more question are coming from this merge interval. I recently solved a problem on Codeforces. I think, let me show you. It's not not a code process, but I think I in a lead code. Let me show you. Level partition. This question I solved. So this is same. This is also the merge interval concept. So most of the questions solved, if most of the question are involving these merging intervals, right? Basically, all the ranges question you have solved, the basically most of the problem they solve you will get. So this is a good concept. Now let's move the next question. Right, we have solved this. Now let's this. What is this question? Merge sorted array. I think I have solved this problem. Interval. Yeah, I have solved this problem. Let me know. But what is this question suggest? You are given the nums1 and sorted the 0 to integer. I am representing the nums1 to single array. Oh, it's a they asked me to sort in combine with this combine this with non-decreasing area. Okay. The final answer should not be written any function, but insist of sorted inside the nums1. Okay, nums1. Okay, final one. Okay, so it's m m is given. So there is m2 is given. Now what? How can we proceed to this? We can use here like merge sorting merge intervals, right? Like we have one, just move one, just move three. So just we have to use three. We can use the merge sorted problem here, right? We can solve here merge sorted interval. That means what I'm trying to do, like it's telling me that without extra space, right? So let's try run it, because with the help of the extra space we can easily solve it out. So three is a good. Let's move the next index. It's a three. It's a good. Let's move the next index. Now it's three. So just we have to put here and then here. Now let's move this 29. So just put here. Now just we have to put. Now let's move the next element. Now just we have to put here the next element. We just move the next element. I think this is right. Wait, if we encounter the I element, we have to put I increase the IIU and J plus plus. This is a good question, right? So how can we proceed like with this one? So this one like more like a structural way. Int I is equal to nums one dot size, right? And and two is there given, right? So I, okay, and two and J, and now we have to just if the if the if the AI, sorry, nums I, nums I, nums one greater one, nums one is greater than the nums two J, J. Just swap the element nums one I and nums two J and increase the I plus plus, right? Else 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 greater if the nums one I is equal to 0. Just we have to do what we have to do. we have to do elements should be uh, it's negative or positive. It can be negative or positive. So I think there might be the problem. Mm, just take now. What? Just take. Just take m int I0 J0. Right. Not take a one. Just reversing. Else. Else. I plus plus. If it is nums greater, then we have to replace. And if like one, two, 1, 2, 2, 0, 0, 3, 4, 5, 7, 0. It's a one. It's a mm, it's a move. It's a one. So I plus plus I plus plus. Now it's a move. Let's move one. If both is greater, we have to move. No, no, no. Just take one. This one is good. Now just take while. Just take while j is equal to n. J is equal to n. Hmm. Nums nums one I plus plus is equal to nums two j. Right. Let's take return. Uh, not taken. One thing I have to doubt like this much distance, this much good. Let's see this. Given the right answer or not, am it's am. So it's like a if it is greater than equal to just swap between the nums and just we are can't taking right 1, 3 and 4. What we have to do here? What we have to do? Just swap now. Just we have to move. So what we have to do? Just take the nums I. Okay. Okay. So what you do? What are you doing? What are you trying to do? You like just if I is equal to m minus one and j is equal to n minus one and k is equal to m plus n minus one. While I greater than equal to 0 and j greater than equal to 0. So what we have to do here, like if the nums nums one nums one I greater than nums of j nums of 2j j like j. Sorry for the inconvenient. So what we can do here, like, so just just we have to store in K1, right? What we have to do store, like 1 K I minus. Now else the condition is nums, sorry, else its condition is nums of 1 and K minus is equal to nums of 2 J minus. Now let's suppose while the J is greater than 0, now just we have to put it like K minus is equal to nums of 2 J minus. So let's see this passes all the test cases or not. I think this should pass that all the test cases, right? What we have to just do here, we have to just merge merge the intervals. Sorry, merge the sorted array, right? So what I'm trying to do here, like if it is greater, if it nums is greater, then we have to store k in the position of k, which nums y. Right. So here we have the main element is 1 to 3, but we have to not to use the extra space. We have to put it this in in the nums one. That's why we are using no spaces and putting this forward. So let's move the next question. So it's a very famous problem, right? If you solve the merge merge sorted array, merge sorted array. I think this is no. This is not a merge. I think it's a merge. It's a problem like a merge interval. No. So like a merge the array. I think sort the array is. I think this is algorithm, right? I don't remember at a present, but I literally solve this type of problem, right? Merge the sorted array. Now let's move the next question. What is the next question? Find the repeating and missing number. Find the repeating, repeating and missing number. LeetCode problem. What you're doing? You are given the index of matrix. Okay, matrix and the value range 1 to n square. For the integer appear exactly once, except the number which appeared twice, and the b is missing. So what is the size? 50. The array length 50 and the character in this and it went to 100. What we have to do here? Like so 1, 2, 3, 1, 3, 2, 2. We can like which is appeared 2 times. You can surely use here what? If you want go to the most optimal way, we have to just like this suggests that array length is 50 and the characters and the integers of the grid I into j is 50 into 50. That means the 200 2500. That means the 2500, right? So we can make a counter variable like a int vector int percent and what, let's suppose grade dot size. So it's like a make a make a what, 2550 take a take a 1 extra, make a and 0. Not what we have to do, just not to do anything, just row, just column row, and just present column plus plus. Now just move from the 0, from the 0, no, 1, and into an I plus 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 plus. If the present I is greater than 1, if present is equal to 0, any order, we can use the any order, right? Now I present is element 1 and the I2 present is 2. The B is missing number and is, if it is greater than 1, so let's int A is equal to -1 and B is equal to -1. So if it is 0, 0, so A is equal to I, else if present is equal to greater than 1, then B is equal to I, and we have to just return A comma B. Let's see this passes all the test cases or not. So it's like a, what is row? Okay, sorry. We have to use grid now. Here we have to use grid, and here we have to use row. Row. We are traveling row, and again we are traveling in a row with all the columns. What is wrong? Wrong. That's okay. Missing number. B comma देखा हजारों दफा आपको. I think this would pass. Yeah, this is the optimal point, and we you can use the like a frequency or a map or a map for checking. All right. So let's see how the other solution is. They all solve counting and math, missing number optimizing. Let's see how it's optimized value, up to date. Yeah, they all are doing same, right? Like this. And Java using hash map. This is the most and the optimal C++. Yeah, and not one single. So there's same. The they either use this one or the map one. This one not in, just great question. Let me count inversion. This is the very best question, right? Count inversion. This is the good question. Not a good, but best, I think. Oh, sorry. This is the become the hard question. Count inversion. GFG. Not a lead code. GFG. Right? You have to count the inversion. What do you understand by inversion? Like this, tell that inversion is the number of pairs that the element I and j, such that the indexes j is greater than the I, but the element on that is vice versa, right? Let's suppose we, let's say 0 and 1, the element on 0 should be greater than the element of 1, right? Then we count as the inversion. Now it's still the, how can we solve it using an optimal way, right? So we can use the set. How can we use the set? Like 4 4 1, not a, not a big deal. 1, yeah, it's 2. So it's 1. Now it's 4, 2 approach. Now let's suppose 3 comes and now it's a 3. Now it's 2, 2 and 4. Now it's 1. So if you want to use the set data structure, Like in the first example, you we have two, one. I'm sorry. What? Yeah, we have one, four, one, three, and five. Right. This much. Yeah, this much. So in the set, we know that we have four, then we have five. So there is no inversion. Now we have one. So there is inversion, right? In what is the inversion? That two and one, and the four and the one. These are the inversion. Now next element comes under the set is three, right? This all the come into sorted order, right? Like four, 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 and the one, and again it's come like a three, right? Now it's come the five. So just we have to calculate the distance from the array. Like we take the set and st. Now we have to just auto, sorry, auto, auto x array. Just we have to find iterator it. And what we have to do, find lower bound, yeah, lower bound or upper bound. Let's suppose 24153. So if we found the upper bound, if we found the upper bound, this becomes our, this become the upper bound, lower bound, upper, lower bound, lower bound. If we find the upper bound, mm, we have to find the upper bound, right? We have to find the upper bound. So st dot upper bound, upper bound. What? What we have to find the x, right? If iterator is equal to st dot in, we have to continue, not a continue, but st dot not equal to s, not equal to st in, right? Not equal to st dot in. What we have to do? We have to find the answer. What would the distance of what? St dot in. I think this is your approach. And we have to just st dot insert. Answer what? X. And what we have to return the answer. I think distance is used like this. Let's suppose. Let's see that it is the using same approach or not. So I think distance is not using. Let's ask the set distance. Set distance. Set distance. Distance. Set distance. I think we can use the chat GPT here, right? Let's use the Gemini. तेरा समाना नहीं आपको use of distance, right? Distance. Distance snippet code. It's taking a lot of time. Ah, I have to just use the chat GPT. Based on your snippet code distance, STDT distance, yes, STDT distance code to trying. What we have to distance, okay. So this way can we use now? Sorry, we can use this, right? Let's suppose if we put it higher, let's suppose this can give the right answer. Oh, okay. What? Oh, sorry. Yeah, I think this can give the time complexity. Oh, it's giving the wrong answer. Why? Why it is giving the wrong answer? If we take the lower bound, this lower bound, then this again give the time. This again they give the time. Okay, so it's upper bound, right? It's sure that's it's upper bound. Then why this become the upper bound? Just we have to find the distance now. Why this give the wrong answer? I think this should be provide the right answer. Bro, just just use upper bound, upper. Why this giving the wrong answer? Like 57, 56, 1, 59, nothing, 10, 1, 2, 3, 7, 38, 91, 10, 38, 28, 741, 78, it's 30, so it's become 1 answer. Now it's a 91, so it's become nothing, and it's become 10, now it's become 3, 4, 5, now it's become 31, 38, 38, lower bound, upper bound, 38 of upper bound, this, and this find 2, and 2, it's become 2, so answer is 2, 2, 1, 4, 1, 4, 2, now it's become 28, now it's become 28, then it's 38, okay, yeah, we have to use multi-set here because this can contain the duplicate, that's why we have to use the multi-set here. Yeah, this can give the time complexity, I think. Yeah, this gives the time complexity, time limit exceeded, because the distance, this takes the n and n time we go of n to finding the distance between the, from the finding iterator to the end, right? So what we have to do, just we have to use the merge sort interval. Using the merge sort we have to solve. How can we approach merge sort? Let me let me what I told in the previous problem, right? So in merge, 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 what we have to do? Merge a int mid, sorry, st mid, 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 int, and now void, sorry, int helper, helper a st, st, and in if st greater than int, we have to just return 0 value, else int answer is equal to 0, int mid is equal to st plus end minus st, divide by 2, divide by 2. Now just we have to move, like, what we have to do, we have to just return the calling the helper function, what, 0 and minus 1 and minus 1, just we have to return this much, array dot size, right? Now what we have to do here, we have taken an answer, so answer should be merge, sorry, helper, what helper, helper should be a and st and mid, right? Again helper should be a mid plus 1, mid plus, mid plus 1 and end, right? Now just I think call the merge, what will the merge, a st mid end, right? And just return the answer. Now what we have to do here, the main problem arises here, like how to proceed with this. So let's say n1 or n2. What is n1? what will be the n1, right? So it's like a mid minus st, and what with the in, it's like a mid minus st plus 1. I think this is the solution. Now let's take temp 1 and oh temp n1 and the temp 2 and 2, right? Now we have to just what to do, 0 and 1 plus plus just temp 1 temp 1 I equal to, sorry, equal to uh, array I plus st, right? Now for the next move we have to just add what to have to do, what we have to add, like 1 0 and 2 plus plus. Now what we have to do, now what we have to do, as temp2 I I equal to I equal to I plus mid plus 1, right? Now let's suppose we have 0 I 0 and 1 take a c and take. Now while while I minus n1 and j minus n2. So this, now just we have to take like a nums I, like a temp and a k value, right? And a k value st. Now we have to just, let's suppose we have 2 4 3 sorry, 2 3 4 and the 1 5 6. Now how many this, right? So we are here and here, we are trying to merging the intervals. Is this the right answer? We are merging right interval. No, I think this is good, this is correct. This is, so what with the answer, answer is n minus n2. देखा हमारी तरह आपको, answer. So just we have to do like a temp 1 I greater than nums, sorry, temp 2j, then we have to use the cnt plus and 2 minus j and the a and the a plus plus equal to nums, sorry, 10 temp 2j plus plus, right? Else we have to move like a k plus plus equal to nums, sorry, temps of j temp 1 of I plus plus. uh, Now we have to just while 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 I minus n1, so we have to just a k plus plus equal to nums temp 1 1 I plus plus, and the while j is equal to n2 I a k plus plus is equal to temp 2 j plus plus. Now we have to just return the cnt, right? This one is good. Let me first observe that this is good or not. I think this might be good. um, I1 ist. So here 0, have to 0, no, no, and 2 should be plus 1, right? And the mid should be end minus mid because this now. So this should be, I think this should be this, right? Now we have to just move in. So uh, let's say this is good or right, invalid, int and what? Oh, sorry, I used the term helper function mid need. I called with need. Okay, need. So this good. This would pass the test cases. Yeah. So this is the problem of a counting inversion using the merge sort. Right. Let me see the solution of this, or let me. I think this is good solution. So copy it and let me comment it out. Right. Solution. 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 Using merge sort and log and like. So this right. Now let's see the other solution, like anyone. So it's I think this gives the time complexity. Like check the other one. Yeah, this is good. So it's the same using same the merge sort intervals. Now let's move the next question. Reverse the pair. देखा तुम्हारी तरह आपको तुम बेकरारी कैसी है तुझसे बिछाऊंगा नहीं आपको. So what we have to do? Given the integer array nums, return the number of reverse pair in the array. Reverse pair is ij where I nums I and greater than I greater than 2 into nums j. Okay. So j is greater should be greater, right? What we have to do? 1 3 2 3 1. I think I solved this problem in contest. Yeah, I think I solved this problem in contest. Let's see how can we use solve this problem. Say should be greater than the. Yeah. You can say that. You can say that. You can say that. Yeah. Let's so it's 2, 6, 6, 6, and 6 and what? It tells you the number of pair, right? Number of pair. It's a number of pair. 6, 4, 6. Now let's not. So 2 greater than 2? Yes. How many? 1, 2, 3, 4. Story. What I think multiset. Use multiset. 4, 6, 6, 6. 2. It's upper bound. So it's take how many keys? It's take 6. 1, 2, 3. Okay. 1, 2, 3. So it's a 3 pairs. Reverse the pair. Nums of I is equal to greater than this. So I don't think this is the concept we are trying to build. I think there is nothing wrong. It's lower bound. There is nothing. It's not going to happen. It's a not. Now let's suppose we have just eliminate this. We are taking here now. We are taking here. Just eliminate this. So we have 2, 4, 6. Now we are 6. So we are checking for the 6. It's 6. Teach. Vector. Any element is Yeah. So we are greater, right? 1 or 4, 1 or 4, 1 or 4, 1 or 4, 0, 1, 2, 3, 3, 6, 6, and 1. 3 into 2 into 6. What we can do here? Maximum product of array. What is this question? These two question and two question. How can we solve this issue? Oh, I think I'm not able to solve this problem. Good. Let's solve today. So reverse the layer. You are given the nums integer and return the number of reverse pair, right? How can we approach like this question? So J. Reverse the pair. So how can we approach like this problem? Hmm, Actually, I solved problem like there is a one boy named Govind who refused to make lunch for us, and just let's not talk about him. Can we 2, 4, 6, 6? Let's find the upper bound. Sorry, lower bound. Nothing. Now let's remove it. Let's move it. Now let's 6. Remove it. Remove it. Now 6. Let's find in the lower bound. There nothing. No one. 4, 6, 6. Upper bound. Upper bound. Find the upper bound. Upper bound. So it's 3. It's a 3 now. 3 greater than 2. Okay. And the pair 3, 3, 6. It's a not a 4, right? So it's a not a 4. It's not a 4. It's like a 3, 2, 3, 3. So it's like a 2. Finding upper bound. Uh, find the upper bound. So it's a 2. So it's a 2. Right? 2. Now again, let's move 3. Just remove the 3. 3 from here. And just find the 3. There is nothing. So it's nothing 0. We have to find like this. Should just reverse it. Now, why we have to reverse it? Just use the reverse technique. I think that the reversing technique is good. If the inversion is good, mm, I don't think so. 2, 3, 1. Oh, that's not. How can we approach? Like, what is the time complexity of this question? If the n 2n, 2n, mm, if the n is greater than the all the 2n's here, there's nothing binding to n. Like we have 4, we have 2, we have 2, 4, 6, 6. This is finding the just find the upper bound. It's the upper bound. There nothing. There is nothing. So it's a 0. Now let's let's delete 6. So delete 6 and what? Now 6. Let's find the upper bound. So it's greater than upper bound. It's 3. 3. Let's find the upper bound. So it's 3 upper bound. Upper bound. So this it's the 1. So it's the 1. Now let's again remove the let's remove the 4. Now 4. Let's become that. Now let's we have to 6 and 6. Now let's check the 2. It's upper bound. It's a lower bound. So there is nothing. There is nothing left. Just we have to there's nothing. Now let's remove this. Now let's remove the 6. Now we have to move find the 2. So it's the upper bound. Then 0. Index, if we find the index, we can't do like the indexing, right? How can we approach this using the another solution, right? If we use the if we use the set data structure like multi-set and storing values and checking for the greatest, I don't think this is gonna provide me right answer. So how or what can we can approach? Like we should be approaching like any other solution or one. If we're using the multi-set value or same the different approach, can be able to solve it. Multi-set value approach. Now, I think this problem is just like the just like the previous problem, right? So how can we approach this using that previous problems? The main question arises that uh, let's see the problems. Hmm, what made my the solution here? All the merging right. Merging should be right. All the merge accepted, all are good. But we have to just find the solution, right? How can we do it using the merge sort? Just like the previous question, how can we do that? So one solution is like brute force approach is right this much. If you ask me the brute force approach, so we can just take like both sides and you we can use multi-set st and 4 auto x nums now auto it is equal to nums sorry is equal to st dot lower bound lower bound 2 into x, right? And the answer should be same with distance it and st dot end. This is the approach and st dot insert x and just return the return the answer, right? So this can be one solution, but it can give the time complexity. Okay, multi-set st multi-set. This can give the time complexity, right? Lower one, it's completely give the wrong answer. Why? I think this can give the right answer. Maybe upper, lower, 2x. I think 2x plus 1 now. If you using this, then use that 2x plus 1. It's a upper bound. I think this can be passed this case. It's, so it can be the value like upper bound integer overflow can't be integer. So it's take a long and the 2 2ll. Now it's give the clearly right answer, right? Yeah, I think this can give the time complexity. Let's say because it's take now, yeah, this give the time complexity. It take this much the year approach, right? There's one more concept like I know I have read the right PB. I think set PBSU data structure. I think I read that problem statement right. The priority based PBDS. I think PBDS. Yeah, yeah. PBDS. This ordered set GNU prerequisite data structure. So this can solve using this we can easily solve the problem statement of this. Like this provide us ordered by value and ordered by key in zero time complexity, that means less time complexity. So let's suppose if we are trying to use here it, if we trying to use this one here, like template, we have to use template and we have to do that's a bigger one. So let's not going to solve this one. Let's use the merge sort interval, right? How can we solve using merge sort interval? Let's suppose we have a mascot and the mascot like so we can solve it at like how. So we have to S and mid just while j is equal to r, we have to like mid is equal to greater than itna, and we have to j plus plus and cnt plus. We have to just temp what we have to do. Let's just the interval, count interval, here the questions. Let's just copy here, just paste, paste here. Let's suppose that int n is equal to nums dot size and return the helper function what nums and 0 and n minus 1, right? Now this is the merge interval, but that means the merge sorting here. Now how can we approach what we have to do here? Just we have to check that in each index we have to do here. Just we have to take this. Hmm? So we have to just count here like int cnt is equal to 0. Now just we have to check from the st and I is equal to mid and I plus plus. Now just check that while 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 what we have to take like while int and long long a dot I should be greater than equal to 2 2 long into a dot j, right? So if it is, so we have to just move this and we have to just add what to add mid plus 1. We have to just add the mid plus 1. Now what we did the j should be the mid plus mid plus 1. I think this is should pass the test cases. Let's say what j is not okay. So j is extra defined na. So, so let's remove here from j and set j is equal to 0. All good now? What what again? T and T. Sorry, the test case first is on the itna y. Remove j is equal to 0, I is equal to 0, I is equal to 0, c and t is equal to n. All good. gentleness. I think all good now. Why it's still fails? CNT0 and T0. So J plus 1. I think this is good. Let's ask CNT. I think we are just checking from the RST dot mid, like mid plus 1, checking if the I greater than the J. So J plus plus. If it is plus plus, then we have to add mid plus 1 add. It's based on the cases of this mid mid plus. Okay. Why we are counting extra, right? Yes, we have to add the indexes now. Yeah, we are count the extra time, right? We have to just reach the position where the element is greater. We have just reach there where the element should be greater than the I I. So if we reach there, we have to just hit plus one. So there, this much element should be less, right? This is the good. This passed all the test cases. Now we have to let's see the next question. The maximum product subarray you are given the integers. So find the subarrays with largest product and return product. They generated answer that will be product arrays of a single. This is the good one. Like we have to take the positive, negative both. So that's it for the today. I can solve. I will be solve this problem tomorrow, right? So that's it. No, no, no. Let's solve the two POTT of today. If it is, it's a hard question. So today I'm not a these two problem I solved, right? So that's it for the today. I was able to solve all these four questions except for the last. If it is able to solve 2 6 or 2 7, something negative 0, negative. We can check our negative and positive numbers. We can't able to solve this problem, right? I have tried this many times and it's again and again give the wrong answer. If positive 0, so we have to let null 5. If positive negative 0, we have to maximize the answer. It's more like a complicated problem. Time complexity is very hard. That's why we are. So we can solve this. Now, okay, thank you. Thank you so much for watching this. That's it. for the today. So that's it for the today. Thank you. Thank you guys.